then. So I'll start off with a quick explanation of why not NuGet. Because there's no point explaining why Paket is useful without explaining the problems with NuGet itself. That is fine. What is the Control plus? Thank you very much. Is that? No.
Oh, you can hold control and do the mouse as well.
What was it? Control.
Two things on top.
It might be alright actually. Oh, yeah, better, yeah.
There you go.
That's not useful because I need to show you the Solution Explorer. Basically, this is a. Just get my FS Proj. This is a new CS Proj style project. I'll just zoom a bit on that. So obviously we know the package references there.
So it's .NET Core.
This is .NET Core, but you can. This is a .NET 4.5 project. You could use the new style CS project with old frameworks on legacy now. One of the things about this is I am using F# here. I obviously need F# core, but I don't know how I'm getting F# core. I'm not explicitly referencing it there. There's nothing that tells me which version of F# core I'm actually going to get in the end. I'd have to explicitly put it in there or rely on Embrace or Chessie to get the highest version that either of them support or the latest version. We don't know. It's whatever package resolution algorithm that NuGet uses under the hood. This was even worse with older versions of NuGet, because if I said I wanted to install Embrace.C#, it would go look at that project, resolve its transitive dependencies, and install each of those on your project. So you install one package, and if you've seen .NET Standard, which has hundreds of dependencies, and those dependencies have X number of dependencies each, that will install a massive number of dependencies on your project, and that's not really what you want. You want to have one. You want to include, one project. You don't expect it to bring in the whole world, the whole of the .NET framework. You want to have a clear, concise definition like that, but you still don't know what you've got or why you've got it for that reason. So that's kind of the reason why Paket exists, is to follow, or to lead really, the push towards using block files to define what your dependencies are project-wide. It's in source control. If you change your dependencies, or if any of your dependencies get implicitly upgraded, because your packet or lock file says exactly why this package has been brought in and why. You can, there's a very nice command line to talk about that. I'll show you what a Paket project looks like first, and just to say, why should I use it, basically? So a couple of things you have at your root level. You have a single executable. Let's just get. So you have a .packet folder. In the packet folder, you have a bootstrapper that goes off and resolves from GitHub or NuGet the latest version of Paket. So if you've ever used NuGet before, you've probably included NuGet.exe, and if you've ever wanted to upgrade that version of NuGet.exe, you've had to physically go in and replace the file in source control or resolve it via some source. Whereas with Paket, you just have the bootstrapper, and in your build scripts, you'll reference it. It will go off and resolve packet.exe for you, and you have the latest version. You can obviously choose which version you want if you want to pin it down, but that is the better way to handle your dependencies. If new frameworks come out, there's very little you have to do to get the latest version, or new features or bug fixes, and you have a very quick turnaround. If you've got an issue, you could normally get a pull request up and he's probably updated it within a day. So it's with NuGet.exe, God knows how long it's going to take before you actually get something available. So following on from that, one of the big advantages is a single source of truth. You have one file that specifies all your dependencies you have, you can have not just NuGet references, you can have GitHub references, HTTP dependencies, and that will obviously go off at restore time, go and resolve that file, bring it in, put it in a good relative path for you to be able to reference from your project. You can group dependencies, so for example here, if you wanted to use fake, but you were building a .NET Core project, but fake doesn't support .NET Core properly yet, other than the alpha, I can go and say, resolve the .NET 4.5 version of fake from X source, and it will put it in a relatively nice folder structure. So if I just get up my packages folder, so because we have a .NET Standard library, it includes, this is all the packages that you have. It's obviously a ridiculous number. You're never going to want to explicitly reference all of them and make sure that they never change. So obviously fake handles all of that under the hood. We've got this folder here called build. So that build folder is the build group. So if you want to load in all of your tools via NuGet or HTTP dependencies, etc., you can explicitly reference them like fake. Whereas if you brought fake in via Paket via NuGet normally, it would add the version to the path. So you can't, every time you want to upgrade your version of cake or version of fake, you have to change the path that you reference it, obviously, because it includes the version number. You can tell NuGet to not include the version in the folder, but it's painful and complicated and awkward to actually set up. So it kind of gives you that flexibility to define your groups the way that you want. So if we just go back to the packet.dependencies file, got it up in VS, haven't we? So, I'm trying to think what I was going to say at this point. Right, move on to the next bit. Obviously, as I said, that's the single source of truth. You define all your dependencies there. That's one of the biggest benefits with NuGet. You have to go around, you have to change all your packages.configs everywhere, attached to every one of your projects. That takes a long time, and you have to consolidate your packages. One actual advantage I want to say is you can specify multiple sources in your actual packet dependencies. So the number of times I've gone to the private NuGet source for my company and previous companies, and I've tried to install the latest version of the package and gone, oh wait, I'm on the NuGet org feed, or I'll have to swap over and then research, and it's just not fun. It's just not easy. With this, you define your sources where you use them within your specific groups. So it sort of alleviates a lot of the issues that you have with the NuGet package explorer.
What is Visual Studio support for Packet like? Does it have any at all?
It has. I'm trying to think. It's not really something that you need to worry about. You don't get. There is a what's it called? Extension that has like a couple of utilities to do like some slight syntax highlighting and things like that. But it's very small and concise anyway, so you don't really have to know too much about it. Packet goes under the hood and rewrites your CS projects if you're using the old CS project format. So all you have to do is reload your solution, and then it will resolve in your packages for you. So you will primarily be using the command line to interact with it, but it's a very simple, clean API. So it's not the pickup isn't that bad, to be honest. So what we have is, so on your project, you've defined all your dependencies up front. So you know what packages you want, which versions of those packages you want. You have to say which packages am I going to get in each individual project. And that's really simple. All you have is a packet.references file, and you have a list of all your dependencies. You just say, I want that package, I want that file, and that's it. So I don't have to worry about which version of F# core I'm going to get. I'm going to get the exact same version for all 100 of my projects, regardless of which one I pick. So that's the packet references file. I'll just give you an example of how that works. So under the hood, essentially what Packet does is it generates this file. This is what NuGet uses to show you that nice graph, or Visual Studio uses to generate that nice graph. It goes off and builds that file under the hood, and that says exactly what version of each project is being used exactly by this project. So we have a look inside of Visual Studio. It still has the Packet, it still has the same UI that you can go down, you can look and say, this is the version of the package that I'm using. So you still get all the nice tooling to explain why you have the package, but you can go one step further. So I've mentioned the command line for Packet. Let's just bring this up a bit. So I've asked, why do I have fsharp.core? So this basically tells me I've directly referenced it in packet.dependencies, and also Jesse embraces dependencies and etc. etc. That is what has brought that package in. So if you ever wondered why do I have jQuery installed or any other sort of superfluous packages, you can see that very, very easily with Packet. Whereas with NuGet, or at least the older versions of NuGet, the moment that you click install on a package, it brings in all of its transitive dependencies, and they're there. You don't know why, you don't know how, but it's very hard to go and then try and remove those dependencies in a sane way. And it's just obviously very confusing. I tried this before, so hopefully this works. So I've just run a command, packet simplify, and that was what it's done is it's gone over my packet of dependencies and it said, I have these transitive dependencies. Is there any way I can sort of reduce the size of my packet dependencies file to just the core elements? So we have a look at our packet dependencies now. We've got rid of fsharp core because it's brought in with all these packages and it is sane for us to do so. So that's gone in our packet.references. Gone as well. So if you want to convert from NuGet, you can run, there is a command under the hood and convert from NuGet, and it will basically go over as best it can and resolve all the dependencies, and what it does is it literally dumps out that horrible package.config file you know and hate from Visual Studio and dumps it into your packet.dependencies. Once you've done with that, you can run packet.simplify, and it goes through and sort of heuristically, not strictly, tries to resolve the exact dependency chain and minify it to exactly what you want for your dependencies. So you get the kind of benefits of having, you can very easily convert projects. I converted one of the projects at my current place, or recent starter place, in about 10 minutes to use Packet. I haven't managed to get that into the main line yet, but it isn't a library, so there's not much in terms of tooling to replace. So it's pretty nice workflow to get it sort of in initially. So I'll just get the. It has a very nice documentation site. It's one of the best things about it. If there's any obscure, weird feature that you want, it's in here and it's extremely well documented. So there are a few concepts, the main concepts that you probably want to learn, and there is packet restore, which is obviously, I look at this log file and I get all the dependencies. That's fine. The thing that NuGet would do was on the new CS project, it would look at that dependency and it would say, right, I need to go off and find all the transitive dependencies, and it could resolve a dependency that you didn't originally have. So it could, if there's a new version of Microsoft.C# package, it may resolve the newest version because you haven't explicitly defined that anywhere. And that could change your behavior runtime, break your app. We've all had those kinds of issues before in some way or another. So the packet install command, what this does is with the recent CS proj introduction, it's not as useful, it doesn't do as much. What this does is it looks at all your CS projects and it says, I have my packet dependencies file, packet lock. I want to apply all the CS proj changes to it. So it'll go over, if you've got the old style CS proj, it'll go over and it'll rewrite all your dependencies, and it's obviously not as clean as a NuGet package reference as you would in the old version, but the advantage is that every time you run that install, it will check that the targets have been included. It will do the same things that NuGet would do on an initial install, but every single time, if it includes JavaScript files, content files, it will rerun that every time. So if you've had a content file included in the past and you've uninstalled the package but the content file is still there, when you remove that project, it will remove that content file as well. So it handles a lot of cases that NuGet doesn't in quite a clean way. It automatically generates binding redirects for, if you wanted to, for all your projects. So you can sort of shim up any incompatible packages and stuff like that. I know that's a lot of pain normally. And it shifts it from any major minor package version to the exact version you want. Whereas like NuGet will give you a range which is from 0 to the package number I expect, the package version I expect, and then go to that exact version. But if you've got actually higher, move it down as well. So there's all these kinds of things that it does under the hood. There is packet update. So if you have your dependencies file, I haven't specified which version of fake or F# core in there. So if I want to get the latest version, I will just run packet update. That will go off. It will update my packet.lock file. So this file is the actual single source of truth. You commit this into source control, and that says exactly what version of any project is in there. It says this project requires F# core greater than that. You can search for F# core and it will tell you the exact version that you actually get, 4.2.3. So that's like a really simple way for you to detect changes in between releases at a high level, rather than some obscure package has been upgraded in one CS proj. You just check the history of your packet.lock and it has all the individual changes that were made throughout the entire project, which is a really useful benefit.
So is that generated when you install it?
That when you run an install, it generates that file. And when you rerun it, when you run an install again, it regenerates it. When you run an update, if you run an install, it will try and maintain this exactly the same and update the CS projes. If you run an update, it will go and update these.
Yeah.
But if you've actually updated the minimum versions of the packages you expect, it will do the same thing and update this again. So that will be generated from scratch when you first run it.
So in the project files, is it the package references or file references? That is when you install a package in the project file, does it reference a specific DLL file, or does it use the new project package reference?
So I'll show you actually, it does neither. So for the new project system, it actually it adds one line, which is that there. That hooks into MS Build, and if you run a .NET Restore, it generates the graph that we saw that Visual Studio sees. So your CS projects are becoming like really clean then and very, very minimal. It's just about your file dependencies. It does rewriting if you want to include. So my packet dependencies has a GitHub reference to an F# file. If I wanted to include that F# file inside of my project, I just reference it with, I think I can do this quite quickly. Can't remember the exact implementation now, so I'll just do it really quickly. But I'll just show you how easy it is to figure it out. So I've got a GitHub reference. I want to include that file. So I will run a Paket install now. So what I've done is I have changed from using the NuGet package chassis to the physical file. So, for example, I was talking about this before, if you were going to use Fable, you can't use .NET DLLs on NuGet because you obviously have to have the raw F# files. Fable works with the translation of the F# files into the source. So if you want to use Chessie is just a single file F# project that gets compiled into a DLL. You don't have to actually, you can have both the NuGet package for your server and you can have the physical file for your Fable project, and that will resolve in the exact same way. So what it's done is it's rewritten the CS project, added in the item, added in that, and then I've got access to that. So the program, is still fine, still resolved, the references. Obviously, if you do try and do assembly loading, you don't want to reference the file in one of your server projects, you want to use it in your client project. But it's quite a nice way to, if you wanted to model your entire dependency graph as just GitHub files and just version them appropriately, if you want to find your models and share between server and client, but you want to put them in a third place, you can do that as well. That's a pretty nice way of doing it. I think that answers your question that you had. It's obviously very different for the old world CS projects, but that is, I think, is a nice way to actually have your CS projects. I think it looks a lot cleaner than having even just your package references inside there. I think they are working on having a packet reference as like a CS project item, so you can actually just have them there. But I think the packet.references is a good usage of that. So there are tons of other features. This one here I want to point out specifically is the packet.template file. If you want to define, or if you want to create a project or a library for consumers of NuGet packages, this is really easy. It's become slightly better with the new CS project format, but it has the same issues of transitive dependencies, etc. When you try and build your NuGet package. All you define is a packet.template file, the same level you do the packet references file. You define a few mandatory things like the type of project that is. It could be a file project, it could be like a DLL project. Any superfluous files, so if you have content files and stuff like that. The nice thing that it does under the hood is it looks at your project, it knows the references that it has NuGet-wise, and it builds the dependencies automatically for you. So instead of having to hand curate the dependencies file, which everyone forgets, everyone updates the NuGet package in your project, then they go to build it and then they deploy it and then they've forgotten to update the minimum version. And that causes just endless conflicts along the line when your package references an older version and things like that. It'll automatically build that under the hood. So for library authors, this is a really useful feature, and I've used this on one of my projects. I had fluent assertions and another library as dependencies of mine, and I didn't have, if I ever update the minimum versions of those, I don't have to touch it. All I change is one file, which is the new version of my project, and the minimum versions of the new projects. It'll just go off and do that for me. I think that's probably me time-wise. I could probably go on all day about the number of features and the number of usages that the project has.
Are there any downsides to using it over NuGet?
I would say the downsides are that you have to learn the syntax. So you have to learn the specific files that you have to know. So it doesn't integrate as well with the tooling that you would like. But I think the benefits, especially in older CS Proj systems, outweigh the benefits massively. Because the packet installs can be much quicker than changing a package reference than they have in the past, especially with the amount of CS Proj rewriting that. If you've got a NuGet package that has a ridiculous number of DLLs in, I remember taking an hour once to do an upgrade of a NuGet package, whereas Packet does that a lot quicker. I think that's mainly it. You have to learn the structure, you have to know it and know the command line. That's the barrier to entry.
And there's nothing specific about it that's F#.
No, absolutely not. I think the reason that it is as popular as it is because it supports C#. Obviously, it's written F# under the hood, but it doesn't get exposed anywhere. There are features in there that are much more friendly for F# developers, like the GitHub references I was talking about. But it's very useful in C# projects as well.